Hi, fifth graders. Today we're going to talk all about how to model the subtraction of different fractions. And just like when we model addition, we can also model subtraction using fraction tiles. And I think you'll find the steps are very similar. First, we'll take out fraction tiles to show both of our fractions. And this time we're going to model them vertically. That means up and down by laying our greater fraction on the top. So let's use that same example, 2/3 and 1/4, but this time I'd like to subtract those two fractions. So I'll still have my two 1/3 pieces first. So I'll put those on top because that's my greater or my bigger fraction. And then to subtract 1/4, I'll take out one 1/4 tile and place it underneath my two 1/3. Next, if the denominators are the same, I can X out or cross out the tiles that are paired up. That's because when the denominator is the same, you're already using the same sized piece or the same unit. Now in this case, we already know that our fraction tiles are different sizes because we have different denominators. So again, I need to find another smaller tile that lines up exactly with our model. So I need to think, what do they have in common? You might remember from the modeling fraction addition that we would use 1/12 sized fraction tiles. So if I have my 1/3 and my 1/3, it took 4 of those pink 1/12 tiles to make 1/3. So that means it takes 8 total 1/12 tiles to make 2/3. And it took 3 of the pink 1/12 tiles to model 1/4. So I can cover over my 2/3 and my 1/4 with 12th tiles to show the same value. Finally, now I can cross out the tiles that are paired up to show my difference. So I can see that this block of tiles all have a buddy on the top and the bottom row, which means I can cross those off. That would show that I'm subtracting away the 1/4. That means the fraction tiles that are left, which is this piece here on the right, are going to show my difference. So in other words, I can solve 2/3 minus 1/4 to be equal to 5/12. Let's take a look at a couple more examples using the tiles. Okay, so modeling subtraction is very similar to modeling addition as we saw. So let's take a look at how this actually plays out. So the first example is 7/10 minus 2/5. So I've already lined up my 7/10 here so that I have that set up. And the one change from addition is that instead of putting the 2/5 next to the 7/10, I'm going to slide it underneath. And that's because what I'm trying to do is I'm trying to line up pieces so that I can show that I'm subtracting away these two green amounts. Now, sometimes you'll get lucky and your fractions will end up lining up perfectly at one point of the problem. So we can see that these 2/5 line up exactly along the edge of this 10th piece right here. That means I can subtract away these pieces to show that my difference is the 3/10. Now I've already drawn that for you. So the way that we'll show that is we'll show our 7/10. I had started that already. And we'll show underneath it the 2/5. Since it lines up perfectly, I'm going to draw a box around this and cross it out. That leftover amount is our difference. So in this particular question, that means our difference is 3/10. Now the next one is 2/3 minus 1/6. So again, I'll replace these tenths pieces with thirds pieces. So I have 2/3, and I'm going to subtract away 1/6. Now in this particular example, the 1/6 does not line up with a seam of the 1/3. So that means we need to find tiles that can replace maybe one of our fractions or maybe both of our fractions so that we're using the same unit. Now, in this particular example, just like with addition, you could do some trial and error and figure out what pieces will fit, or you can look at the denominators. You might be able to see a relationship. I know that 6 is a multiple of 3, so I'm going to try to replace those 1/3 tiles with 1/6 tiles. So since two 1/6 tiles line up perfectly with the third, I can replace these 1/3 tiles with 1/6 pieces because they're exactly the same size. So I'll put these right on top so that you can still see that they're exactly the same size as the 1/3. Now, when I subtract away the 1/6, I'm left with 3 orange 1/6 tiles. So I started to draw this one for you too so that you could see what we did here. So I started with my 2 1/3 tiles along the top, and I know I need to subtract away the 1/6. To keep track of the fact that we changed those 1/3 tiles, you might want to draw dotted lines to show that you split these into sixths. So now I didn't do a very good job of keeping my spacing correct on this one, but that would show me that I had a 1/6 tile left here, a 1/6 tile left here, and a 1/6 tile left here. That shows me that my difference would end up being 3/6. Let's take a look at a couple more and we'll do them start to finish all together. So this time I'm going to use that 2/3 to start again. But instead, I'm going to subtract away 1/2. So now I have 2/3 minus 1/2. Just like last time, I don't have a nice even lineup. And I can't turn a 2 into a 3 by using even numbers. So I need to find a tile now that works with both a denominator of 3 and a denominator of 2. I know that 6 is a multiple of both 3 and 2. So I'm going to replace my 1/2 and my 2/3 with 6 pieces. So I know that I have 4/6 to represent my 2/3, and I would end up needing 3/6 to represent my 1/2. Now I can show that when I'm subtracting the 1/2, which was along the bottom, I'm subtracting out 3/6 pieces. So what's left over then is just one last 6th piece. So let's draw that model out. So I had 2/3, 1/3 here, 1/3 here, minus 1/2, 1/3, 1/3, and then 1/2. I know this was split into 6 pieces. This was split into 6 pieces, which tells me that I subtracted this part away, and I was left with a 1/6 orange tile. So that means my difference there was 1/6. All right, let's take a look at one more example. This time I'm going to have 5/12 minus 1/3. So I have 5/12 pieces that I'll put on my paper. These are tiny little slivers. Minus 1/3. Now this one, like the first one, lines up nice and perfectly. Now I could replace this 1/3 with 4/12 pieces. That's actually what you're doing when you're lining things up. You're basically saying that you recognize that there's an equivalent fraction to be made out of the tiles that you used in your first number. But for our model, I can show this by simply saying that if I were to subtract this 1/3, I would be left with 1/12 piece. So that means I will have my 5/12, 1, 2, 3, 4, 5, minus my 1/3. So I'll fill these in as 1/12 each. And I'll show that I'm subtracting this full group here, which leaves me with 1/12 as my final difference. So that's how you would do some subtraction of fractions as you're modeling them as you go through. Thanks for watching.